Okay, real quick, we're going to get into lesson 7.4, the algebra of functions. Just as we can add, subtract, multiply, and divide numbers, we can do those operations to functions. Let's take a look at example 1. We're given f of x, we're given g of x. They say find h of x, which is f of x minus g of x. Well, if I'm going to find f of x minus g of x, all I have to do is say f of x here is x squared plus 1 minus, now here's the thing, you need to put in parentheses. We're subtracting all of g of x. Make sure you put parentheses around that. Again, this is what h of x is, and we have h of x equals this subtraction. Well, distribute a negative. We've been seeing that all year long. And we will get negative 3x. Negative times a negative is a positive, so this becomes a plus 2. So what is h of x? Well, combine your like terms. You have an x squared, you have a minus 3x, a 1 and a 2 add up to a 3. Now this is your h of x function. They say state the domain though. Domain, guys, there are two main reasons why something can fail to be part of a domain. Domain, by the way, always is going to refer to x values. You want to see if you are dividing by 0 or if you have a negative inside of a square root. If you do, that would require us not to include that x value. As you look here at h of x, there is no possible division by x, no division by 0. Of course, there's no square root to talk of. So the domain, we're going to say, is all reals. What that means is there is no way that an x value can lead to a division by 0 or to have a negative in a root, in an even root. So that's really what we've got for our domain. Let's take a look at number 2 real quickly. H of x is a division of two functions, f of x all over g of x. Now, of course, f of x is x to the third. Down below we have 2x. Now, before we simplify, I just want to make a quick comment about the domain. The domain is all possible x values. I'm going to say immediately for this domain that x cannot equal 0. And of course the reason why is that would cause division by 0. Anytime you divide by 0, you have to throw that particular x value out. So continuing on, we could actually reduce and cancel. We could say x to the third all over 2x. Well, you know that x to the third, really there are like 3 x's up on top. This x will cancel, leaving us with just 2 up above. So our final answer would be x squared all over 2. Now I want to notice something right now. In this simplified form, there is no x down below in the denominator, yet our domain still must restrict x equaling 0. So always look for domain restrictions before you cancel. Number 3, we're actually not going to have problems like this. We're going to skip that for the moment. But let's talk instead about compositions of functions. Compositions of functions are going to look quite a bit different. What I want you to see is we are, just like before, given two functions f and g. F of x is 2x plus 7. G of x is x squared plus 1. But now we are going to be given something very, very different. We're going to be given f of g of negative 2. Now I want you to understand that this is not f times g of negative 2. That would be written very differently. If that were the case, we would say, and I'm going to say this is not f of negative 2 times g of negative 2. Or f of x times g of x. When it's written in this regard with g being put inside of f, it means that we're going to follow an order of operations. We always have to do the inside part first. We're going to evaluate f, but at g of negative 2, first find g of negative 2. Now, back in Algebra 1, I hope you saw this, that g of x was equal to x squared. Many Algebra 1 teachers do the following here at our school. They'll say g of a blank equals blank squared plus 1. Wherever we have an x, we replace it with an empty parenthesis blank. And that can really help us because it means when we're finding g of negative 2, it means we need to replace x everywhere with negative 2. Wherever there's a blank, put in a negative 2. And of course, the order of operations say we must do powers first. Negative 2 squared is actually negative 2 times negative 2, which is 4. And 4 plus 1 is 5. So g of negative 2 is really a 5. So where does that lead us to? Well, now we're going to evaluate f of 5. So let's look at f of x. F of x was 2x plus 7. We can do the same thing. F of a blank is equal to 2 blank plus 7. We're saying, look, inside of f, we saw right up in here, inside of f is g of negative 2. We're seeing that g of negative 2 is really going to be a 5. So we're really asked to find f of 5. So plug in a 5 everywhere where we have a blank. 2 times 5 is 10. 10 plus 7 is 17. What's our final answer? F of 5 equals 17. So let's review. What did we do before? Well, going back to up here in this yellow highlighted section, just as always with nested parentheses, you must work from the inside out. First, find g of negative 2. It means plug in negative 2 into g and get an answer. We did that off to the side here in the mid part, and we saw very quickly that g of negative 2 was 5. Well, then we said, well, that inside part, g of negative 2 is really 5. 5 is the number we're going to be substituting into f. We did that at the very bottom of the screen to get 17. So let's continue on with this and see if we could do a few problems very quickly. Let's take a look at page 2. Two different functions, f and g, but we're supposed to evaluate g of f of 2. Well, I hope we know that we always work from the inside out. First, we find f of 2. Now, f of 2, well, we can see that f of a blank is blank cubed minus blank plus 1. Everywhere where we see an x, we can put in a blank. So I'm going to put in a 2 here. This is 2 cubed minus a 2 plus a 1. Well, 2 to the third is 8. 8 minus 2 plus 1. 8 minus 2 is 6. 6 plus 1 is 7. So we're seeing that f of 2 is equal to 7. What does that really mean? What I've highlighted in yellow is really a 7. Now we have to find g of 7. Well, look, g of a blank is equal to 2 blank squared minus 10. So if I'm finding g of 7, I am going to put a 7 wherever I see a blank. By the way, the calculator can work this out. 7 squared, of course, is 49. 2 times 49 is actually 98. 98 minus 10 is 88. That's what g of 7 is. G of 7 is notation. It has nothing to do with saying g is multiplied to 7. Please don't feel like you would divide both sides by 7 right now. Your final answer is just 88. Real quickly, if I may, let's skip number 5 just for a moment and do 6a. For 6a, always go inside out. We're going to say find g of 0. Well, if we're going to find g of 0, look right here. G of a blank is 3 blank plus 4. G of 0 would be 3 times 0 plus 4. 3 times 0 wipes out to 0. 0 plus 4 is a 4. What are we really seeing? We're seeing this. That inside part, that inner parenthesis, is really the number 4. So what I'm really trying to do is I'm going to find f of, well, we just saw that g of 0 is 4. Now, f of a blank, we can come back over here, is blank squared minus 1. So plug in a 4 into this blank, we'd plug in a 4 over here. 4 squared is 16. 16 minus 1 is 15. And again, don't divide by 4. This is just your final answer of 15. All right, well now maybe something a little surprising. Let's go back to number 5. Usually kids have a question about something like number 5. Understandably, they'll say, well, wait a minute, look inside that composition. G of x is what I'd have to do first. Kids will say, well, g of x, there is nothing to evaluate. And you know what? In that regard, you're absolutely right. There's nothing to work out. G of x is very simply x squared minus 2x. So do you know what we're really going to have to do is find f of x squared minus 2x. That might look a little funny at first, but g of x is not a single number like we've had before. It's the expression x squared minus 2x. Well, here's why that blank method can be so helpful. Look, f of a blank is 3 blank minus 2. Wherever we see a blank, we're going to put in x squared minus 2x. We put x squared minus 2x in that first parenthesis. We're going to put it in right over here as well. So look, instead of plugging in a number, we're plugging in x squared minus 2x. Distribute a 3 real quickly. You'll have 3x squared minus 6x minus 2. That's your final answer. There's nothing left to combine. So in a way, it's less work because you don't have to find the g of a number. G of x is just that expression. And you plug that expression into f. One last one real quickly. Take a look at 6b. 6b might be a little surprising. Sometimes kids ask, well, is this a typo? You know, I see a G and a G. Yes, it's actually written correctly. It's not a typo. A G of x is quite possible. This 3x plus 4 is really what g of x is. So we have to find g of 3x plus 4. And like we wrote up above, g of a blank is 3 blank plus 4. So right now we're saying, hey, instead of substituting in a number like 7 or 6 into the parenthesis, plug in a 3x plus 4. We're going to write that in right in here. We're almost done. We just have to distribute a 3. We'll get 9x plus 12. And of course, 12 plus 4 is 16. 9x plus 16 is our final answer. This is what g of x really is. And that's as far as we can take it. So some different types of problems here. But I hope this is helping. Best of luck to you guys.